says to solve the system of equations by graphing. And you can see we have 7x minus 5y is equal to 25, and 7x is equal to 5y plus 25. These equations look very similar. They both have 7x, they both have a 25, they both have 5y, just the signs are different. Well, if we were to write this second equation in the same form as the first one by bringing the 5y over to the left side, we'll notice that, well, let's see what happens. If we subtract 5y from both sides, well, the 5y's will cancel out on the right, and on the left we'll have 7x minus 5y. So this equation would look like this. 7x minus 5y is equal to 25. Well, you can see that's exactly what the first equation looks like. So these two equations in the system are exactly the same. So when you graph these, you're going to get the same line. So any point on this equation is also going to be a point on the other equation. So that means that there are infinitely many solutions to this system of equations. So we can tell that already because they're identical equations. But we still have to solve it by graphing. So how do we graph an equation that's in this form? Well, we've looked at using the method where we find the x and the y-intercept to do the graph, to draw the graph. And so let's try that. That seems like the natural thing to do. If we try to find the x-intercept, we do that, remember, by letting y equal 0. Well, look what happens. If y is equal to 0, you get 7x minus 5 times 0 is equal to 25, which means you get 7x equals 25, of course, because 5 times 0 cancels out. If we divide both sides by 7, we get x is equal to 25 over 7. And if we write it as a mixed number, we see we've got x is equal to 3 and 4/7. Now that's not going to be any fun to try to graph, especially in my math lab where we have to be very precise. So this method, while it seemed like a good idea at the time, we can see here that we're going to have a problem trying to graph 3 and 4/7. So we need to scrap this idea and try to graph this equation another way. And the other way to do it is to solve the equation for y. So 7x minus 5y is equal to 25. Take that equation and solve it for y. Well, we solve that for y by, first of all, subtracting 7x from both sides. And that leaves us with negative 5y is equal to negative 7x plus 25. And then we divide, everything by negative 5. And when we do that, we have y is equal to, well, negative over negative is a positive 7/5 x. And then a positive over negative is a negative, well, 25 over 5 is 5. So here's the equation solved for y. And you're probably thinking, well, that didn't do me any good. Thanks a lot. I still have a fraction here. How is that any better? Well, here's how it's better. Now that it's in this form, we can find 2 points by picking any x value we want. X is the independent variable. Let's let x be whatever we want it to be. Well, letting x equal 0 is always easy. If x is 0, then y is equal to a negative 5. So that one's easy. In fact, that's the y-intercept, by the way. But we're not going to find the x-intercept now because we already ran into trouble doing that. Let's pick an x value that will work out nicely. And the x value that we want to pick here is 5. And the reason we choose x equals 5 is look what happens. And when you plug x equals 5 into this equation, 7/5 times 5 minus 5, well, the 5's cancel. That's why we did that. We end up with 7 minus 5, which of course is 2. So our second point is 5, 2. So now we have these 2 points we can graph, neither of which has a fraction. All right, so let's go over to my math lab and draw that graph. Here's the graph. I'm going to magnify it, although it doesn't really help much when we do that. And I'm going to try to graph, or I'm going to graph those 2 points. Let's start with 0, negative 5. It's a straight line, so we select the straight line tool. And I'm going to find 0, 5. Now, as I move the point around, you notice up here in the corner, the ordered pair shows up. So you can make sure you're on the right one, even though it's kind of hard to read the graph. So as I move my mouse around, I'm looking in this corner too. I'm going to 0, negative 5, and there it is. Now, I might have messed that up. I think I'm on the right spot. 0, negative 5. And then the other one was 5, 2. So over 5, up 2. There's that point. And I think I've got them right, but boy, it's hard to tell by looking. And if you're using a touchpad on a laptop, it can be really difficult to do. So it's much easier if you have a separate mouse. Well, let's see if I landed those on the right spot. I'm going to check answer. Yep, I made it. So the other equation is the exact same graph, so we know there are infinitely many solutions. So just check to be sure, and that's how we do it. Now, the only reason I worked this one out in particular is I wanted to show what you can do if in your effort to find an x or y intercept you run into this messy fraction. Well, you have to turn to another approach to find your 2 points.